In this presentation, I would like to take an opportunity to discuss about the standard ISO 5817-2014, especially Annex C, which is newly added in 2014 and it supersedes 2007 edition. So this standard basically it is not a product-based standard, but it is much more utilized as a recommended practice for the product-based standards like ISO 15085 and system-related standards like 3834. They recommend this standard as a practice, and this in this standard we are going to discuss what is newly added in Annex C and what are the new quality levels they have defined in this Annex C. So the main purpose of this standard is this standard provides three different quality levels like B, C, and D. D is moderate level, and C is the intermediate level, and B is a stringent level. It defines these quality levels defines dimensions of the typical imperfections. So what are the quality levels and that we have discussed it, and what is criteria for choosing this quality levels? The basically these quality levels have been can be chosen with five aspects like design, processing, mode of stress, static or dynamic, consequence of the failure, and service like temperature and environment is been added here. So quality of welded on the basis of type, size, amount of selected imperfection. So these are the criteria for selection of quality level. Even economic factors like cost of welding, inspection, testing, and repair also can be taken a choice for selecting this quality level. So this standard is applicable for material thicknesses greater than 0.5 mm, and for the material especially applicable for steels, alloys and non-alloy, titanium and titanium alloys, and nickel alloys. And for the welding processes like SMAW, SAW, GMW, GTW, plasma and oxyfuel. And for all welding positions, this standard is applicable. And for the welds like butt and fillet for plates and pipes are applicable. Mode of welding like manual, semi-automatic, and mechanized uh, and automatic welding. All these modes are applicable to this standard. So how this standard is categorized? The the type of imperfections are divided into four subgroups like surface, internal, and joint geometry, and multiple imperfections. Joint geometry and multiple imperfections they have given two categories, and for the surface they have given 24 categories of different types of welded discontinuities, and for internal imperfections they have given 13 discontinuities. All these discontinuities I'm not going to discuss, especially I'm going to concentrate on the Annex C, what new thing is been given there. So basically what is imperfection? It is nothing but a discontinuity in the weld or a deviation from intended geometry, lack of continuity. So two more definitions like short imperfections and systematic imperfections is very important to refer this standard. So what is short imperfection? If a weld length is greater than or equal to 100 mm, imperfection shall not be greater than 25 mm in a 100 mm weld length. If a weld length is less than 100 mm, imperfection shall not be greater than 25% of the length of the weld. So what is systematic imperfection? Imperfection that are repeatedly distributed in the weld over the weld length to be examined, the size of the single imperfection being within the specific limit. So now let us come to the Annex C. In Annex C, what it is given? Annex C, they have given the criteria for welded joints which are subjected to the fatigue load. So basically, let us discuss what is. We're not going to discuss entire subject on the fatigue. Just a fundamental thing I am going to share here. So what is the fatigue? Fatigue is nothing but a failure of a component subjected to the cyclic loading at a stress considerably lower than the yield stress of the static loading. So how this fatigue failure can occur? Fatigue failure can occur in a three different stages, like initiation of crack, propagation of crack, and complete rupture or a complete failure. So initiation can occur due to the stress concentration. This stress concentration can occur due to the imperfections in welded joint. So IIW, International Institute of Welding, has provided recommendations for this fatigue classes. They have given a fatigue classes. This fatigue class is nothing but they have provided stress range at n number of cycles. N number of cycles means 2 into 10 power 6 cycles. So what is the stress value that can be bearable by a welded joint if the welded joint is subjected to the cyclic loading at 2 into 10 power 6 cycles? So that is given in this Annex C. The value of fatigue class is a bearable stress range related to the 2 million cycles of two-sided survival probability of 95%. So they have tested different types of samples, and they have plotted this stress results in a normal distribution. In a normal distribution of a confidence level of 95% means the 5% values are rejectable and remaining 95% values are acceptable in range. These acceptable values, in these acceptable values, 75% of the tolerance limit of the mean corresponding to the IAW recommendation. They have taken the values which are nearer to the mean of 75% of the values from the 95%. They have taken these values and given as a criteria. So that they have defined in Annex C. So basically what they have given and what is the useful of this SN curve and what is the basic need of this one. So there are for a fatigue failure, they have given different models are there to calculate the life of an component. So there are three different ways. One is SN approach, another is strain based approach, and another one is LEFM approach. So now in these recommendations they have provided only SN approach. So how much of stress we can put on a part for a given number of cycles that they have given it. So first of all, before doing any calculations, first we need to have a material, what type of material it is, and we need to calculate the endurance limit of that material. Endurance limit is nothing but below this stress the component can survive for infinite number of cycles. So we need to have ultimate tensile stress and endurance limit, and we need to calculate the correction factor for the endurance limit here. Why we have to calculate is because the values which have been plotted, we cannot take the direct stress value of endurance limit as a basis of an acceptance criteria, because if that is been taken in a practical way, if in a situation it may fail or it may pass. So we need to add a correction factor to the endurance limit. How we can add it? Based on the load, size of a component or a surface preparation, temperature, and reliability of this coupon. So all this can consider as a correction factor, and we have to add it to the endurance limit. So based on the corrected value, we need to draw a SN curve. S log S is nothing but amplitude stress which is placed on the y-axis, and number of cycle is placed on the x-axis. So all the stress values at a given number of n cycles, all the stress value been plotted in a hyperbolic curve. Now we can select any at any point at n value, we can calculate the s value. So this is given here. So we are very much concentrated on at n number of cycles, like 2 million cycles per 2 million cycles. So what is the stress value at 2 million cycles, so that it is given as an endurance limit for that component, so that it can live up to infinite life. So what are the three quality levels which they have introduced here is FAT 63, FAT 90, FAT 125. So earlier they have given levels D, C and B. Here the criteria given, the criteria which is given for the level D has been removed, and extra they have added FAT 125. It is very higher stringent than the level B of table number 1. So level C63 covers fat 63 and lower, level B90 covers fat 90 and lower, and level B125 covers fat 125 and lower. If the limits are not present in the C63 or B90, limits can be referred with level C and level B, which is given in the table number 1. And the limits are not present for the B125, limits can be referred with the level B. For a level B125 is not generally achieved as well at condition, and fillet wells have been excluded from this level 125. Here we can see the SN curve which is plotted with different fatigue classes. So we are mainly we are focusing on at 2 into 10 power 6 at 2 into 10 power 6 cycle. So at 63 MPa and 90 MPa and 125 MPa. So the welded component can sustain to the infinite life at given stress with a cyclic loaded at 2 into 10 power 6 cycles. So that we can take from this slide. So what is the different criteria given in table number C1? They have given 3 different levels, like level C63, level B90 and level 125. They have not given these criteria for all imperfections which they have they have addressed in table number 1. They have taken some imperfections which they have experimented and they have tabulated in recommendations. They have taken the imperfections for a given thicknesses like 10 mm and above, and the levels they have defined in these tables are B125 maximum. It is like undercut is also not permitted, shrinkage glue is not permitted, and as well as you can see sagging or incompletely filled glue is also not permitted according to level B125, and root concavity is not permitted, and the spatters are also not permitted here, and elongated cavity or wormholes are not permitted, or slag inclusions, solid inclusions, or flux inclusions or oxide inclusions are not permitted. And they have newly added new imperfection like angular misalignment 3.3. So here we can see that the criteria given for C63 is angle should not be more than or equal to 2 degree, and for B90 angle should not be greater than or equal to 1 degree, and for B125 angular misalignment should not be greater than or equal to 1 degree. So these are the changes given in 5817. I think you have gained some information, and thank you.